Yeah, hello everyone. So this is a question from JEE Mains 2026, 28th Jan evening. You can pause your video and go through the question. And the chapters involved in this question is amines. So this is a question from amines. And so when we go through the question, this is talking about, you can see total number of alkali insoluble solid sulphonamides, okay, obtained by reaction of given amines with Hinsberg's reagent is. So basically they are talking about, so here before we go deep dive into the question, we should know a bit of the theory that what happens when amines, whether it is 1 degree, 2 degree or 3 degree, when they react with Hinsberg's reagent. So Hinsberg's reagent is used to differentiate between primary, secondary and tertiary because different amines behave differently with Hinsberg's reagent. Hinsberg's reagent is nothing but, I'm drawing the structure. This is our Hinsberg's reagent, and the other name of this guy is benzene sulphonyl chloride. So all these three type of amines, they react differently with benzene sulphonyl chloride. And upon reaction, so whenever amines react with Hinsberg's reagent, so let's say they formed a reacting mixture. So that reacting mixture is basified, or you can say it is reacted with a base or an alkali. So as it is given in this question. So when the reaction mixture is basified or reacted with KOH, which is an alkali, so all these three kind of amines will behave differently. So we will see how they do it. For example, if you take a 1 degree amine, if you have a 1 degree amine, so for example, we are taking Hinsberg's reagent plus R NH2. This is a primary amine. So what will happen? Cl from here, 1H from there. So we will get this S double bond O, S double bond O, NH R plus HCl. Okay, and these guys in general are known as N-alkyl because they have an alkyl group, benzene sulphonamide, and these guys, since they contain an acidic hydrogen, this is the acidic hydrogen on this nitrogen atom, so therefore when we react these guys with KOH, they dissolve in KOH or they react with KOH because they contain an acidic hydrogen. So acid plus base, we will get a salt. So when we dissolve N-alkyl benzene sulphonamide with KOH, we get this salt. And the K plus comes from the base. So this is the salt that we get. That's why it is soluble in KOH, right? So therefore, so the primary amines, they are soluble, they form something which is soluble in KOH. They are dissolved in KOH. Okay, now coming to secondary amines. 2 degree amines. So secondary amines, upon reaction with Hinsberg's reagent, so we have Hinsberg's reagent plus NHRR. So this is a secondary 2 degree amine. So this H and this Cl is going to go and form HCl. So we will get S double bond O N R R, and these guys are known as N, N dialkyl. In general, they are known as N, N dialkyl benzene sulphonamide. and as you can see, they don't have any acidic hydrogen on N. Therefore this does not dissolve in KOH. Okay, they don't dissolve, or you can say they are insoluble in KOH, right? So therefore secondary amines, they react with Hinsberg's reagent to form something which is insoluble in KOH, right? And the 3-degree amines, as you can see, we are showing Hinsberg's reagent, S double bond O Cl plus N R R R. You can see this, since it is tertiary amine, this does not have any hydrogen for it to combine with Cl. So therefore 3-degree amines don't react with Hinsberg's reagent, right? So this is how they differ, how the primary, secondary and tertiary amines, they differ with Hinsberg's reagent. Now coming back to the question. So it says that total number of alkali, that is KOH, insoluble solid sulfonamide. We want insoluble, alkali insoluble. That means we have to choose 2nd-degree amines from these list, 2-degree amines from this particular list. So so let's draw their structure one by one and check which one is a secondary amine. So aniline is this. So this is a primary amine. Nope. N-methyl aniline is this. So this is a 2nd-degree amine. So this is one of the answer. This is correct. N-methylamine is correct. Third, methanamine. Methanamine is CH3NH2. Not gonna work because this is primary. N, N dimethyl methanamine is N CH3 CH3 CH3. So this is tertiary, so not gonna work. N methyl methanamine. N methyl methanamine is CH3 NH CH3. So again this is 2 degrees, so this is going to work. Phenyl methanamine. Phenyl methanamine is benzene ring CH2 NH2. Again you can see this is a primary amine, not gonna work. N-propyl aniline. N-propyl aniline is benzene ring NH CH2 CH2 CH3. So you can see this is 2nd degree, so this is gonna work. The next amine in the list is N-phenyl aniline. N-phenyl aniline is benzene ring NH benzene ring. So this is 2nd degree, again this is gonna work. Next is N, N dimethyl aniline. So N, N dimethyl aniline is N CH3 CH3. So again this is tertiary, not gonna work. Allyl amine is C double bond C, then NH2. Again this is primary, not gonna work. And the last one is isopropyl amine. Isopropyl amine is CCCNH2. Again you can say this is primary, not gonna work. So therefore we can see that there are 4 of them. One, this is the first one, this is the second one, this is the third one, and this is the 4th one. So therefore the answer is going to be 4. Thank you.